This is the Amp Hour Podcast, recorded February 11th, 2013. Episode 132, Vacuuous, Vortex, Verification.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Chris Gamble's Analog Life.
What's up, nerd?
Welcome back, nerd.
Thank you very much. I went on my little nerdy trip to Melbourne.
Yeah,
it's quite exciting.
Quite nerdy. Yeah.
The whole 1 hour plane flight. I actually got out of... I got out to the real world.
Yeah.
Which
You're
I don't
meeting
get
people.
to do much these days.
Yeah.
I'm actually, talking to people.
Talking.
Real humans, as opposed
Weird.
to you who I've never met. You could be
Yeah, I don't
like
know I could.
You
We need
may
to do
not
like the
even be
Turing
human.
test.
Yeah, exactly. Yes.
Bleep blorp, bleep blorp.
Did you hear about the new Alan Turing doco coming
No.
out? Yeah.
I
I
have to
don't
look
have
that up.
details on it. That just, you mentioned Turing there, and boop, it just popped into my head. Yeah, I just saw yesterday that there's some Alan Turing documentary, and there's actually a trailer for it that I watched, and it looks really good. Yeah.
Yeah, I'll have to check that out.
Huh.
It's that kind of stuff's usually awesome.
Yeah,
Obviously
exactly.
the Turing story is incredibly sad in general, just how he was
that's right.
treated.
Yep.
But these kind of historical things about technology, that's actually another thing on the list here too. There's a series that PBS, which is like the public television,
Yep.
in the U.S., they're doing this huge series in Silicon Valley right now, and I started watching it at lunch.
Is it about the
one
history?
day.
Is it like
Yeah,
a
it's
chronological?
All about this. So there's preview, there's chapter 1, in the 60s, Noise goes to Silicon Valley, the Wild West. I mean, so this is like continuing going on. And maybe this is old. Maybe I'm just finding this now, but I started watching it, and it is spectacular. I was like, I have to turn this off right now, not because it was lunch, but because I knew I would just keep watching.
Right.
You know?
Yeah, and you'd waste your whole day. Yep.
Yeah, and so they're starting from like where Silicon Valley doesn't exist, and then going from like the Traitorous 8 and the whole Fairchild. Is it Fairchild? Yeah.
Yes.
And then Noise and Intel, and every direction that it goes. So very cool stuff.
I've got to get it. Okay, please send me details.
It's all free online. We'll put the
Done.
PBS,
okay,
man.
there goes the rest of my day. Okay, so all
Yeah.
PBS stuff is actually, every PBS show is available online, is it?
I don't know about all of it.
To Australians, because
definitely...
often they limit that shit to Yanks only.
Oh, well, I'm sure we could find some way for overseas.
I'm sure I can get it.
People to get it, but no, you can also purchase it too if because there's Watch Online and then there's DVDs and they have ads and stuff, which is weird because in the States, PBS is publicly supported, so like there's no ads, but now going online it starts to. But whatever,
right?
I'm used to that stuff.
That's all right. Doesn't matter.
Sweet Silicon Valley nuggets of wisdom.
So yes, I'm back from Melbourne. So
how was it? What did you do over there?
I did a few things. The main reason for going was to visit the new Agilent. Well, to see Agilent's new mobile calibration truck called the shipping container. Sorry, officially called the Voscow, but unofficially called the TARDIS. Which I'm not supposed to say that because that's not in. That's not official in
no
any
one's
way.
listening.
But no, exactly. And it was very cool. Yes.
Is it because it's blue? Is that why?
Yeah, well, it's blue and white, yes, and it's bigger on the inside than it
because it expands outwards.
It expands outwards, yes. So it's the name is very apt, and it replaces their old one. So it's very cool.
I had talked to some people on Twitter about that kind of same thing for like doing that for like a mobile workshop, like CNC machines and like laser cutters, doing that kind of thing in there. And apparently there's a couple out there, but nothing like, there's no like, a school could buy one yet.
Right.
So hopefully that kind of thing will happen eventually. Because I think that's a really good form factor,
Right, like a shipping container kind of thing. But they're very expensive too. So are you talking about one that sort of goes onto a site for like 6 months or something, or are you talking like you convert a bus or something? See, that'd be cool.
No.
Like if it was truly portable,
Right, yeah, the portable would be nice, but you probably need to hook stuff up to it. I mean, like hooking three-phase up to a bus might be kind of wonky. A huge ground strap off the wheels or something. Yeah, but it's cool form factor. I really like when that kind of thing happens. But you're right, to transport a shipping container isn't cheap. So.
No, it's not. It's very expensive, and there's actually not much room in a shipping container, like width-wise, because they actually had one before, and it was like just a regular, they just got a regular 20-year-old shipping container they bought on eBay or something for $50, and they and they converted it into a cow lab, and there was no room in there to breathe. It was by the time you got all the rack gear in there and everything. And I've posted photos of all the rack gear, and you'll see video as well. And if you imagine a 20-foot-long shipping container with one side of it just completely filled, floor to ceiling with rack gear, $3 million worth of gear, by the way, in that shipping container. Yep.
Is it just like standard corrugated steel, like?
No. They had it specially, specially insulated and all that sort of stuff. And of course, they had it heavily modified so it could expand out on these rails. So
right.
It's much more luxurious in there.
What's the ventilation like? Was that pretty noisy and crazy? I mean,
no. It was it's aircon, of course, but. You didn't really. I mean, you didn't notice the aircon over all the fans in the racks going. So the aircon.
Okay, so it just vents internally. There's no like external venting, like data centers do or anything like crazy like that.
Oh, no. Well, no, I don't think so. There's just an aircon on the wall inside. That's kind of So, but
it's kind of crazy cool. Because if you do that kind of, like, air quality does matter for that kind of stuff. I mean, I've heard stories about like test gear coming back from like really rough environments and just being like completely coated inside.
Oh
just like gunk.
Yep, it's they've got it. The temperature has to be in a cow lab like this to get certification. Has to be within a 5 C window, and.
Humidity matters, right?
And humidity, 30 to 80% window or something like that. So it has to. So if you go to a place which is completely dry with no humidity, then that's hard because you've got to actually get it up there. And or if you go to a place with 100% humidity, well, you've got to get it down. So
right.
Yep. But they did the job well.
Calibration's not easy,
No.
Especially when you get up into
in something that's, a metal box, which if you put it in the middle of the Australian outback, right, which is where they send this thing, you could fry eggs on the top of this thing, right?
Yeah.
So,
right.
But
that's the reason they insulate it, right?
That's the reason it's
keep
fully
the hot
insulated.
out, keep the cool in.
So they said even without the aircon on, it's pretty, fairly decent inside. But of course, all that rack gear takes is expending a lot of heat. So if you turned off all the gear, it'd actually be quite nice inside because it's all insulated and stuff. But you turn on $3 million worth of test equipment, and and of course they just power it all up. Like
why is it $3 million?
So,
is it because of RF gear? Is that what really gets it up there? I mean, I just trying to imagine.
Yes,
$3 million.
This is I don't know if it's the only portable cow lab in the world that's rated to 50 gig, but. 60 gig, I think.
Ooh,
so it's rated from, it's rated all the way from DC to 60 gig. So, it's very like most cow labs won't go, they'll go to 300 megahertz or, something like that.
Okay, so now the real question, why the hell do they need this in the Outback? I mean, why don't you just ship your 50 gig, spectrum analyzer to a lab in Sydney?
Because it takes time. If you've got a lot of gear, then your entire production facility or your radar or something else goes down. These are used in, why is it used in the Outback? Well, there's lots of sort of, secret military installations. Even we have them here. Mostly US,
Yes, take that, bastards. Conspiracy theorist.
And
they're everywhere.
They have to send them out on site because, when you buy... if you've just got a regular production facility and you're using, $100 multimeters and stuff like that, or $1,000 bits of gear, right? You can afford to buy spares, so that you sort of send one lot. Yeah, you swap them out and send them away for Cal. But when you're using, a $200,000 network analyzer, spares are, it's not that cheap to keep
you still
spares.
ask. You got to ask your boss. We can get a spare of this, right, boss? Yeah, of course. We need it.
Yeah, it's cheap at twice the price. Yeah.
Yeah.
What was it from? Famously from the movie Contact. Why build one when you can build two for twice the price? That's a famous quote from Contact. I love that.
Yeah.
Why build $1 trillion bit of gear when you can build two for
It's a stimulus program.
Exactly.
Well, that's cool, man.
So it's nice.
Are they doing any of the gear? Are they calibrating any of the gear for the square kilometer array at all?
Probably. I would assume so. Yeah.
You didn't ask these questions? I mean, should I have given you a list before you went?
You probably should have. I had a list as well, and of course I didn't follow it.
Of course, right.
Yeah, because in the heat of the moment, you're,
right.
Everything goes
out
the
of a metal
window.
box.
Yeah, exactly.
Do they go all the way over to Perth?
Yeah.
Yeah? Oh, yeah? The whole country?
Yeah, it goes all around the country. It's all around the country. They ship it. Yep. They put it on a truck and off it goes, or a train, or whatever, and off it goes. Of course, because, of course, you can't fly a shipping container on a plane, so it's all road freight. And,
I'm sure you could.
Well, maybe if you had one of those big Russian Antonovs. Oh, yeah, I'm sure.
Right.
If the customer wanted to pay for it, hire an Antonov or a,
Need it tomorrow.
Galaxy Starlifter or whatever it is.
Yeah.
Yeah.
Well, I saw you also met someone from the Raspberry Pi Foundation in your little hackerspace video.
Yes, I went to the Melbourne Hackerspace. That was a last-minute thing. I turned up unannounced. I just thought, I'm in Melbourne. Yeah, why not? I'll jump on a train. Took me bloody an hour and a half to get there, but But yeah,
which is always I think it's a great idea when you're traveling to go visit hackerspaces, try and visit if you can get tours of places and anything like that. It's just good to, because you'll meet people that are like-minded. If not, even if there's nothing going on, you'll meet people.
Yeah, exactly. And there was Alex, the head software developer for the Raspberry Pi, just hanging out at the hackerspace helping someone fix his mobile phone. It's great. Well, he was the reason he's in the country. He's from the UK, of course. He was in Canberra giving a talk on the Raspberry Pi. So he thought, came all the way to Australia from England, I may as well see the place. So he decided to go to Melbourne, and he just turned up at the hackerspace, and he's going to Sydney. So I assume he'll go to the Sydney hackerspace as well. And he thinks the same thing, right? You travel to a new city. Well, you're a nerd. What are you going to do? Well,
go where the nerds are.
Yeah, exactly. Visit a hackerspace. Why not?
Hope there's beer. If not, go out for beer afterwards.
Right.
Or tea or soda, whatever you need.
Yeah. And it's fantastic. And
that's good.
And everyone that's there, Jonathan Oxer, who we've had on the show from Freetronics, he was there, and Andy from the who founded the Hackerspace, who's doing that one of the biggest Kickstarter projects of all time, that Wi-Fi Life Expo, which we've talked about. That came out of the Melbourne Hackerspace, and
it seemed like they pushed a lot of stuff back out. I was watching that video, and it seemed like as they were walking through the lab, they said, and we redid this, or we worked on this component of that, and so it seems like a nice active space. That's really cool.
Yeah, it's cool. So there you go. I've been to the Melbourne Hackerspace twice. I haven't been to the Sydney Hackerspace once.
I think you should do that this year.
Yeah, this year. Yeah.
It says you're an
opportunist. Tells you something about my
Tells you lazy piece of crap.
My social, my social inclinations.
Yeah. Oh. You have to tell your wife to push you out of the house more often.
Right. Night. Yes.
Well, speaking of the Raspberry Pi, they just announced interesting new module for that. It's actually, there's been boards that have been released. Like a bunch of different companies and everything have been doing plates or whatever they're calling them as actual like mountable attachment boards for the 26-pin header. But they just announced that the core team is actually working on a camera-based module to actually plug in directly and then have that as a native device, I believe.
As in built into there'll be firmware support, or there'll be software support for it, I guess. I'm not sure how it all works with the.
Well, what I was assuming is that since this is a mobile processor, that a lot of the firmware will already be kind of synced in for phones which have a lot of camera needs, right? So that's why I assumed it was being done by the core team. But it's interesting just thinking about a lot more of the applications that you can do. I mean, there's an example video on Hackaday which we'll link in, but just simple processing. It turns a network attached video into a very, very easy commodity now. I mean, it's like another $20 for the board, I think, and then the $35 baseboard, and it's $55, and you could set up a pretty sophisticated network. I'm not going to say simply because I have no idea what it actually takes. I mean, I know it says it runs OpenCV, but easier than probably getting down into the firmware of like a Logitech webcam, and I think probably even cheaper than, unless you're buying them, at 5 megapixels right now. That's better than my camera, possibly my webcam.
And you're not going to believe it. This was actually an idea I had a couple of weeks ago.
I believe that ideas are a dime a dozen, Dave. Aren't you the one that
They are a dime a dozen. This goes to show.
Yeah.
I was going to combine a Raspberry Pi with a camera module and run OpenCV on it.
Yeah.
And here it is.
There you go.
Ta-da!
Well, got the jump on you. I've had a board now for about 6 months. No, not 6 months. That's way too long. Maybe 3 months. And it's just been sitting there. I've got
a whole box of them, dude.
I know. Well, I mean, but it makes you wonder too. Like, I mean, so they've sold 1 million units. I mean, I wonder just how many are dormant. I mean, they could be said for a lot of units, right? A lot of dev boards and stuff like that. I think
we've talked about this before, and I'd say is a large majority.
Yeah,
I would say it's probably a majority of boards. People have like powered them once, up once, or maybe even like me. I haven't powered up my Raspberry Pi yet. I've got one. It's been sitting here, along with 50 other boards I've got, and and they don't do anything with it. So it's
Yeah, dev board syndrome can be very dangerous. I feel really guilty with that too. Like when I'm
exactly.
Talking to a vendor and they're like, "Oh, well, we can get you an evaluation board or dev board." I'm like, "Yeah, sure." And then, they come back about 2 months later. "Oh, so how's that working out for you? You been writing code for that thing?"
Yeah, right.
Oh.
Oh, that
if
thing,
any of them
right.
are listening, of course, I have been writing code for it, and it's been my primary thing. But no, of course not. I mean, work gets in the way. It's like if you're lucky, you get to write code for it and get to learn all the quirks, right? That's why I like platforms like this are great, because then when people design apps and like pluggable boards for that kind of thing, it's so much less of the hassle there, right? I mean, you don't have to go and learn a whole new compiler. You don't have to learn all the little quirks and how to get the serial console up and everything. It's just, yeah. So there's something to be said for standardization.
Do people use their Raspberry Pi? Please tell us.
Well, I'm sure that's the thing though. Like, there's a power distribution, right? I mean, like, so. The top 1% of users are also outputting probably 90% of the work.
Exactly.
They're the developers really, and the rest are just kind of consumers.
Yep.
But I mean, there's a lot of good projects out there, so people are learning. I bought Matt Richardson's book, Getting Started with Raspberry Pi, so that'll help. Hopefully, when I get to it.
Yeah, exactly.
I open the book. The book looks nice. I like the book.
Right.
Yeah, and so it's like that kind of thing, but again, it's the accessibility that helps too, because when it's $35, right? A lot of people say, "Well, just have it around." And now when I have a new project, and I have this, I blew up those other dev boards I was trying, right?
That's right.
So,
oh boy. You want to know what else was cool? I saw in
what else?
Well, there's 2 other cool things I saw 3. Well, one was the Agilent Standards Lab, which is different to their Cow Lab, by the way. There's
that's like an on-site kind of thing?
No. Well, yeah, it's an on-site thing. But there's actually a significant difference between a Standards Lab and a Cow Lab. So, which I'm sure
Standards
I'll probably...
Lab calibrates the stuff that the standards, or that the Cal Lab
calibration labs uses. Exactly.
Yeah.
Yes.
Right. So it's like if there's a standard resistor, they go and measure it on a daily basis or a weekly basis.
Yes. Or the standards lab calibrate the calibrators, and I just uploaded a video on that last night.
Yeah, I saw that one.
Yep. That was just a quick 5-minute impromptu chat. So the problem with those impromptu, chats is that, we talked about, you should have gave me, a whole list of questions I could have asked. Well, it's like you're just having an impromptu chat and you're filming it, and you get what you get. It's sort of
yeah.
I know.
Wait.
I could have asked 20 million more questions. And, well, you just don't think of them at the time because you're in a hurry, or or it's just an informal.
You're
chat.
Starstruck. Ooh, a calibration engineer.
What do I do with him? Oh. Oh boy, yeah.
It's a tough business to be in. The Keithley lab around here. There's a standards lab here too in Cleveland, and I didn't go near it. It scares the crap out of me.
Why?
It's like I don't want to touch anything, and I don't want to break anything. I don't know. It just seems like that's beyond my pay grade.
Got it. But they were complaining to me about how they're all going to die out soon because all these companies, all these original equipment manufacturers, they're starting to shut down their Cal labs, and they're vitally important to keep them going and. And keep keep all of the knowledge there and stuff like that. And he went, well, look, I'm 50 and I'm the youngest guy here, and it's
wow.
Well, and every manufacturer is outsourcing their stuff. Like here in Australia, we had the Department of Defence had their own standards and Cal lab, right? That's all gone. Because some bean counter went, well, just outsource all that,
Right.
And then everyone else is doing that. And then several other, large-scale companies just here in Australia had their own standards and Cal lab to the point where, well, there's only one left, and that's the Agilent one.
Yeah. Yeah, and it's good for their business.
If some bean counter at Agilent says, well, we're not making enough, margin out of that, well, we'll just can that. And, well, what
hopefully
are we left
they just
with?
say, well, we're the only ones, we should turn up the price, but maybe they won't. Maybe they just count, they don't think.
I don't know.
But it's tough, too, because there's shipping there's calibration implications in shipping something, right? I mean, if something gets vibrated, I think we talked about the, what do they call it, the stereophonic effect? What's someone where? No, not that one. Where it's actually like the mechanical stresses induce electrical changes, right?
That's the microphonic effect. That's the microphonic effect, but that doesn't damage components. It's actual vibrational modes which damage. Shock and vibrational modes which damage components.
Right, so, and then heat cycling from shipping and everything too, right?
Yeah,
There's just shipping is not the way to do it with tailed equipment, right?
Well,
that's the reason for the truck.
The amazing thing I found about the Agilent Cal Lab is it's one of it's the standards lab. It's one of the best in the world, and a lot of calibration gear from overseas is shipped to the Melbourne lab to get calibrated. And I went, what? That's weird.
Maybe I'm wrong then.
Yeah, even
well, maybe
stuff
that will work then.
From the US comes to Australia. So. There's not many of these labs left.
Do they cross-measure, okay, so here's what we think it is, and then we'll send it to you, and what do you think it is?
Yes, all of these standards labs, that's how they work. They each, they cycle gear between each other and keep them all in constant check, and
It's like a measurement chain letter.
Yes.
Send this standard 100 ohm resistor to all of your friends. Or else a great curse will befall you. I never did chain letters. I was just on the cusp of that. I never. No one ever sent me a chain letter, Dave.
Right.
So sad.
Oh, it's terrible. Yeah, I used to get them.
Yeah.
In the
all
mail,
I got was Nigerian
they were
princes.
Right? Okay, Nigerian princes. Oh boy. And but there's some gear you can't ship because you've got to leave it running 24 hours a day, 7 days a week, like the cesium beam clocks, which is another interesting thing. I had a look at, and you'll see the video on it. It might be today's teardown, even though it wasn't really a teardown. We just sort of popped off the lid on this thing. But
I saw your picture of that on Twitter.
Ah, right, yeah. It's one of the original atomic clocks from 1971, I believe it is, that flew on the planes in opposite directions around the world and proved Einstein's theory. That clocks do
Time
actually
dilation.
run. Yeah. So it is actually one of the original clocks used in that experiment. And they were just going to throw it out, but somebody actually went, oh, look, this is the original one used, and we'll keep it. So, yeah, it's awesome.
See, like being around that kind of stuff, that just wigs me out. Like being around like historical stuff like that.
Yep.
Because I break so much stuff on my own that I figure the more important it is, the more likely I am to break it. I mean, like
Right. Well, you can't
So-
really break this. It's already broken because the cesium have a limited life. They only have about a 20-year life, and then all the cesium burns off, and
It
you
decays.
have to replace the tube, And so, well, this thing doesn't work anymore. It's just too old.
oh.
I'm sure
Well,
if
if
you
someone
put a
had told
new
me that, I
cesium
would be
beam
fine
in
then.
there, well, yeah, exactly. So it's not really a teardown, but I'm busy at the moment, so I might just make that today's teardown video. Teardown Tuesday is just 10-minute talk about popping the lid off this cesium clock. So sorry in advance, people.
Yeah,
I'm
nobody
busy.
watched Dave's videos.
No. Well, I'm probably already going to get complaints about all this, but, I think it's interesting stuff. Like, I've already gotten complaints about the calibration videos. Oh, this is boring as batshit. Well, yeah, okay. Yeah,
Well, yeah,
to
but you're a
many
measurement
people
nerd,
it
so
is, right?
you're just doing what
exactly.
you like.
Yeah.
It's good for them.
It's interesting to me anyway, so
Yeah,
tough titties.
exactly.
Yeah. Anyway, that was a very cool thing to see. The other cool thing I saw, because, well, we might as well talk about my trip.
Might as
Because
well.
these things don't
Like I have a
usually happen
choice.
to me, right? Exactly. Well, I don't get out much, It's a big deal. And I went to the Australian synchrotron.
And so, what is that?
A synchrotron is like it. It's like a particle accelerator, like the Large Hadron Collider,
Oh,
et cetera,
okay.
right? But it does accelerate the particles, right? But the difference between a synchrotron is that they actually store them. They put them in a storage ring. So in a regular particle collider, like the Large Hadron Collider, they just put them around in opposite directions and then they just slam into each other, right? Bang, and then
Yeah.
you get measurement data from that. Whereas a synchrotron, actually, they have an acceleration loop, but then it goes into a storage loop, and they can store that current. They actually define it as current. So this can store up to 200 milliamps of current for like a week or something like that in this storage ring.
and is that just
and,
based on the efficiencies of like the helium cooling of the and like the efficiencies of the magnetic rings?
Primarily based on the vacuum, because you get a loss as the
Okay.
beam travels around. It's straight. If you aren't in a absolute pure vacuum, it hits other molecules and
Oh, then
gas and they sort of it degrades. So you'll see on my video, you can actually see like the little sawtooth waveform as it's pumping more current in to keep it a constant current. So I actually got that shot of, I took a shot of the oscilloscope that was measuring the main beam current in the whole storage loop. And you can see that little sawtooth effect as it just went, oh, I've dropped below a threshold, I'm going to pump a bit more energy into the storage ring.
So it's
really
basically
cool.
like an electron. What are those called? Oh, jeez.
Wah.
Wah wah. Never
Time's up.
mind. Yep.
Anyway, very cool. And the idea of these is that when you've got a storage ring like that, then every time you bend this beam, i.e. it goes around, because people think these things are a circle. They aren't actually a circle. They're actually straight bits and then a tiny bend and then another straight bit, tiny bend, because every time you bend one of these beams, it creates synchrotron radiation. And that's, it actually emits synchrotron radiation. So at each bend in this storage ring, it emits synchrotron radiation. Then you can put that into what's called a beam line, which has the particular measurement gear you're after. So this thing, because it's, a huge, big ring the size of 2 football fields, right? You can have up to, this one has 9 functional beam lines coming out of it, but it can have up to like 30, I think. So you can have 30 different instruments all measuring different things all at once. You know, so you can have one measuring the quality of the beam, another working on, surface physics, another doing X-rays and stuff like that. So you can get different wavelengths of light from the infrared right up to the hard X-ray stuff out of any of the beam lines from the same beam. It's really cool.
So what I'm hearing is if you stood by the bends, you could become the Hulk because you'd get irradiated. Is that right?
Well, you could. It depends on what comes out of it.
Right.
Because, I actually put my hand inside the beam that was coming out one of the beam lines. Yeah, because it was the visible spectrum. It had passed through visible filters. So, there's quantum wigglers. There's different instruments. That's actually a name. I think I got it right. And there's undulators and wobulators and all sorts of things which actually change. These are real names that change the properties of the beam coming out of the main storage ring. So if you want to X-ray stuff, then you would have an X-ray gadget which you put... confabulator that you stick in series with the beam, and it converts it into the X-rays you want. Or another one, which I stuck my hand in, was the visible one. So they want to measure the visible quality. Well, yeah.
Hey, check this joke out. We're going to play on this guy.
Yeah.
This guy from Sydney came all the way down here. We're going to irradiate him.
Force for it every time. Suckers. It's very cool. So there's all these... different measurements all going on at once. And, it's primarily one of the major uses for this thing is like to measure surface properties of stuff. So it's like a scanning electron.
Oh, cool.
No, it's probably not like a scanning electron, but they move the object.
Like bounce stuff off of other things?
They bounce stuff off other things, and you can determine the makeup of the entire surface, or if you've got X-rays, the entire 3D surface of something. So so basic research into basic materials and stuff like that. Really cool.
Air compressor.
Huh?
That's what I couldn't think of before. It was an air compressor. Yeah, when you're storing up the storage ring. That's what that was. I had to get it out. I was just waiting for a break and a pause. Air compressor. That was the one.
Yep.
All right.
So,
you know what always bugs me? I know this is another annoying superhero reference, but did you see in Iron Man 2 when he builds that so-called particle accelerator in his house?
Oh, yeah.
And then he bends the beam with a prism, but there's nothing going through it. It's like, come on. I'm sorry to get all nerdy there, but come on.
Right.
Like, seriously, that would never work. It would run out, like, immediately. Unless he had a storage ring somewhere. Maybe he had a storage ring. Who knows?
Yeah. There you go.
Well, that is really cool, though.
It is very cool. I've never been to a big physics thing like that before, which was very much in danger of being shut down, by the way.
Right. That's the kind of thing where
incompetence,
Yeah, it's hard to see. It's such a long timeline with those kind of things, right? It's like, okay, well, you're bouncing, X-rays off something today, right? And then someone looks at it and said, well, why the hell you need to do that? And it's like, well, we don't know. We're doing research. We don't know what we're researching yet. That's what research is, right?
Well, this one's a bit better in that respect. This one, they have lots of companies coming to them. Look, I want, I've got this new material. I want to see, how it performs or something like that. That they had another example where the rice industry came to them with a grain of rice and they cut it in half and they put it in the beam and they were able to scan every molecule in there and tell them where all of the nutrients and stuff were, right? Really practical stuff. So all these companies come in and
every
pay
grain
to
of
use
rice.
it. Well, no, one is good enough. It's representative.
Right.
Right. So anyway, you've got all these commercial companies coming in, right? And they pay to use it for whatever purpose they need to.
Yeah.
So
that makes sense.
As well as doing the basic research stuff, there are tons of unis, sort of doing basic research on things.
But there's no money in that. Come on.
No, it's not. And that's what, it was threatened to shut down. It was only, even the New Zealand government had to buy into it to help save it. They actually bought a share in it, yeah.
Jeez, you got the Kiwis holding you guys up, huh?
I know.
Oh,
ridiculous.
Good way to go, Kiwis.
Man, unbelievable.
You were my favorite country from down under. Better than Australia. Go, Kiwis.
And then, of course,
just to pay Stave off.
And then, of course, all the scientists who worked there got the heebie-jeebies that, oh, my career's being wasted here in Australia working at this synchrotron that's going to get shut down. So they all started fleeing, to other synchrotrons around the world, where the career had. Yeah, so,
CERN.
It's crazy. Anyway, CERN would be great.
It would be.
I actually was invited of a tour. He said he could get me a tour of CERN as well.
Oh, fancy. Look at that.
Yeah. All I have to do is get there.
Celebrity on our hands.
Oh, boy. Unfortunately, it's one of those last-minute things, Like, this was, actually arranged, at the last hour. And I rocked up and sort of, these are real busy people, working on, trying to keep this thing running and doing research and everything else. And but they spared the time to give me a round. But, sorry if it comes out a bit fragmented, the old video on this one. It's it was shot on the run, folks, literally, as I'm running through the facility. Yeah,
that's okay.
It's not easy. We're talking about this before the show. I need a cameraman and, and a sound guy and an editor and, everything else.
I'm sure we could get some volunteers. I'm sure we could.
Right.
It's just you'd have to pay for them.
Yeah, bugger that.
Yeah, buy them lunch at least.
No, well, yeah. I have to feed myself and Sagan.
Yep. And hopefully your wife too.
Yeah. Well, she's back at work now. She can feed herself,
Okay, there we go.
Yeah.
All right, well, that's good, man. Sounds like a really good trip. I mean,
it was fun.
It's good to have you back. Did you get a chance to listen to last week?
No, I didn't. Sorry.
No, that was a good interview. Andrew was a good guest.
Well done. Thank you very much, Andrew, for... sorry I couldn't be there. Well, we were going to have Mike on. We did announce that the other week, didn't we?
Right. Yeah, we'll get to him in coming weeks.
Postponed.
We wanted to make sure you two could argue, so that's the reason behind that.
Right, okay.
We were sure that you two were going to have a go at it, so...
Why would we argue?
I don't know.
Argue over what?
I don't know. You two...
you pommy bastard.
Best practices, I don't know.
I don't know.
Aussie versus UK.
Yeah, there's lots of rivalry there.
Oh, yeah.
Not as much as with the Yanks, though.
No.
I don't know. It's different. Actually, yeah, the rivalry is more between us and the UK, I think. The Yanks are someone we just love to hate. We have that love-hate relationship with.
With like the Palms, you can fight for second place, right?
Right.
Anyway.
Boy.
So I have a thing going on around here. I just got some populated boards back in. Right. And I wanted to talk. Is this for home or work? This is for work.
Are you going to tell us what they are? Or is it a super secret?
No, I
secret
cannot.
Squirrel?
Secret squirrel.
All right.
But I wanted to talk about board bring up, and what you do and what I do, and just I thought that was a good topic for, because I was actually looking for it, and there's like no checklists online. That seems like something that would be helpful. Is like do this, do this, do this, do this. Obviously, it's going to be different for everything. But
I was going to say, it's pretty obvious. If it's your design, you're going to know what's needed.
Yeah.
But there is one basic tenet, right? Is to make sure it doesn't
blow up,
release the smoke. Yeah, is it drawing the current you expect? So that's the first thing. You put it on a current limited supply. You wind the wick up, and does it go over current? No or yes. Yes, you're in deep shit. And no, well, great. Okay, I can at least power this thing on. It may not do anything, but because there's a fault somewhere in it, but at least it's not drawing excess current and the magic smoke's not going to escape. That's got to be number one, surely.
Another corollary to that, I would say, is if you do have sensitive circuitry and you have the option to leave that off at first. I know that's kind of weird to do, like selective. If you can, sometimes when there's surface mount stuff, you can't do that. But if you can pull a jumper or something like that.
Well, I was going to say, if it was sort of like a first cut development version of the board, you might have included jumpers on there to isolate sections of the for this specific testing purposes. Because sometimes you don't jump right into the production board. You're just doing a development test bed, perhaps, which will have all that sort of cool stuff. You know,
Right.
it'll even have little current shunts in there so that you can put your current meter in there and measure the current of different parts of the circuit, so you don't have to hack the board and stuff like that. So
yeah, that's a good idea too. I've got one of those on there. I've been a little 0 ohm happy. I put those
right.
everywhere.
Okay. Yeah.
I like those better than the jumper, the dog bones specifically because
I like the 2-pin headers because then you can actually, especially for isolating power and stuff, because then you can get in with your multimeter and actually stick, leads in
you're
there.
saying because it's easier than pulling up like a surface mount resistor and tacking on wires, that kind of thing.
Yeah, exactly, which is really ugly, So.
Yeah. Yeah, so, I get all the usual stuff on there. I've got auxiliary circuits to try a couple things, because this is an early board for me, but,
right.
auxiliary circuits to try stuff out, a lot of different population options.
Mm-hmm.
So that was all, I thought of all that stuff beforehand. I mean, so that was good. Something that was asked about before the show, someone asked me was, did I put test points on there? Because I was complaining that I'd already thought of other things that I'd forgotten. But I did remember test points, and that's always a good one too. I don't know. Do you prefer through-hole test points or surface mount?
Through hole.
Yeah.
Yeah. Then you can solder a pin into them. You can and you can hook a probe on permanently without having to, put wires.
I got
in
hooked
and
on these
stuff
little.
But it depends if it's a development
ones.
or a production board, right? Oh yeah, those little loops, those little through-hole loops. Or
the surface mount.
You can,
surface mount. They're just like a metal surface mount loop. I really like those because it's a little hard with the angles to get a clip on there, like for probes and everything. But usually it's okay as long as it's not like real space constrained with tall parts around it. Right. So those are cool. Now,
did you build this board yourself, or did you have someone else assemble it?
No, someone else assembled it, and someone else did the layout. But I was working with them on the layout. Which,
right. Okay. Right. So it's not a solo design then.
No. Right. I had done a test board before that where I did solo design. I did everything like it was just a test coupon really, but this is kind of getting into it. So yeah, it's tough, man. I definitely prefer doing my own stuff, but I mean, with workflows and companies, it's just something you have to do sometimes because your bandwidth gets lowered so much. It's just like you have to translate from instead of just brain down to finger clicking on a PCB program. Like a layout program, it's now write an email or go talk to them or call them. It's just
humans.
No, I didn't mean that. I meant this. Let me show you. And it's like the person I was working with was actually really good. It was often my explanations that were stupid. It's just the human element of getting that communication down. Ugh, it's terrible.
Yeah, it's not easy sometimes.
Right.
Mind meld, Vulcan mind meld.
Exactly. Yeah.
Oh boy,
that's a tough
part.
But
that probably still would work because people process and think things differently.
Yeah.
So.
Yeah. It's true. I guess it's helpful if you can do like, I guess you've said before, and I agree with it. Like if part placement on a PCB is so much of the job, it's probably 80% of the job. So if you can get a hand in that always helps, and that's what ultimately ended up doing it. So,
right.
But yeah, other bring up stuff I was thinking about. I don't know. Like I guess power's a big one, obviously. Mechanical fit and function. If you've got like packaging was another one.
Yep.
Like stress points. Another thing I was thinking about is there's actually these this enclosure I'm using has like some hold down features, and I was actually trying to push it in there, and I'm like, oh crap, like you could start to feel where the board starts flexing, and you can actually get because that's the worst kind of errors when you have those flexure errors where you're pushing down on something and it sounds bad, but it doesn't ultimately look bad, but then a trace is broken or the resistance goes up on it a lot.
Well, that's pretty serious if you're if it's being flexed that much that shit's changing. I mean, I think you've gone
so
a bit
use
far.
A hammer? Is that what you're saying? No hammers?
Oh boy.
Yeah.
Yeah. That's a red flag, folks.
Yeah.
If something's changing value or doing something because you're flexing your board, man.
Yeah. I mean, that is bad. But I mean, you have to prepare for the worst, right? I mean, especially if your manufacturing is remote, that's another problem because the lead time on when those errors come back to you, like when they're those soft errors like that, because if it's not like a complete break, if it's just like a resistance change or, like you start to, like a trace changes capacitance or something like that, and your design is sensitive to that for God knows what reason, that's not going to show up easily.
Holy crap, these things are pretty subtle, like a track-changing capacitance or a track-changing resistance. These things are rarely happen.
I know, I'm just saying worst case.
What the hell are you doing to this board, man? Is it sitting on the top of a Saturn V rocket or something? What's it?
Yeah, right, yeah. No, it's not.
Man.
Did you see that video? Who was it, Fran that did that video?
Yeah, Fran did the...
Saturn V?
Yes, awesome. She reverse engineered the Saturn V. I haven't watched it in its entirety. I watched some of it. It's great.
Yeah, it was like an LVDS controller or something. I didn't watch it either, but I saw some of the stills from it, and it's pretty cool. I don't know how she got a hold of that thing. It must have been like a surplus buy or something.
Somebody gave it to her. I think way back in the day, who used to work. She's had it for a long time, I think.
Oh, cool.
Is the story. Yeah. But, all that sort of stuff lost in the annals of time.
It doesn't even take time for that kind of thing. That takes a hard drive crash, and you could be screwed.
Right.
that takes a CAD program conversion, and you're toast. You'll never get that back. Oh, we thought tape was going to stay around forever. People don't use tapes anymore.
Man,
we had
that
40
reminds
megabytes
me of the
storage.
That reminds me of the Voyager. Was it the Voyager? Yeah. No, it was the Pioneer 11. There was an article in IEEE the other month. Yeah, I've got it. I do have it here. It's within reach, but I won't get it. They did an article how the Pioneer space probe. I think it was Pioneer 10 or 11. I think it was 10. Which is the farthest object from us now, right? Because it's been going since the late 60s or early 70s or something. And
is this the one with the gold plate on it? Is that the one?
That's
that just
Voyager.
left the solar system?
Voyager had the gold plate. Yep, the one that was done by Carl Sagan. Yeah. That's on Voyager. And anyway, this is the earlier ones from the Pioneer, and they had lost all of the tapes. Like the tapes had all just vanished, and then somebody found a copy of them hidden under some stairs or something in an old building at NASA or something like that, and they tried to recover the data, and it was like, all this stuff they've just lost. Even the Apollo, even like massively important to the human race, right? Original footage from the Apollo 11 moon landing, lost, right? Like completely, like all the original tapes, lost, gone. Like it's hard enough reading the back, even if you do have them, let alone just losing these things.
It's nice for like when they do recover that stuff. It makes for a good story, but it'd be better if there was like triplicate copies of everything. That would just be better for history, Yep.
Anyway, the Pioneer story was that, they wanted to recover all of this original data because they wanted to reanalyze it using modern techniques to prove that... I'm going to get this wrong. To prove some aspect of relativity or so. No, the spacecraft, that's right, the spacecraft showed acceleration. Right, it was like the data they'd hinted at this data for decades that the spacecraft was actually accelerating, and they couldn't account for where it was coming from, where this acceleration, and they thought, maybe it's due to dark energy, right, which they're trying to detect and all that sort of jazz, right, which makes up like 90% of the universe apparently, and they thought, maybe it's that, and it turns out no, they reanalyzed all this data, right, that they found on these lost tapes or backups of the lost tapes or something, and they analysed it, and it turns out that they're almost 100% confident that the acceleration was due to the heat effect coming from the thermal generator that's powering the unit itself. So the heat coming from that is bouncing off one of the metallic parts of the spacecraft and actually giving it a slight little nudge. Just that heat, like that solar sail thing, right? Yeah, and that was enough to accelerate it. And they actually, it took them 30 years to figure this out, and they finally said they've nailed it. Yeah, it's not due to dark energy. Sorry, folks. It's or anything other mysterious. It's just the heat coming from the 60-watt generator on the on the probe. Oops.
Yeah. I figured it was just going to be a measurement error or something. Like a
no.
Oh,
it was.
I guess their probe's broken.
Yep. No, it was real data. They were actually right for the last 30 years. They've been looking at it, going, "This thing's accelerating. Why?" And they couldn't figure it out.
Yeah.
Sure enough, some smart cookie came along and, reanalyzed the data.
That's what I wonder about. So, they're still measuring data 30 years on. They're still using the same code. Obviously, the guys that did the Mars Curiosity rover did some amazing code as well.
Yep.
But I just wonder about, how electronics are made now versus back then. There's just so much focus on quality because it started out so crappy. I just wonder if you send the same stuff into space.
I think the quality might be a bit of a red herring because systems were much simpler back then. They were larger and much simpler, therefore inherently more reliable. Whereas nowadays, right, like something like the Curiosity rover, right, it's got some heavy-duty physics and engineering and, electronics and software packed into that, right? Yeah, it had 800,000 lines of code just to land the thing, right? Yeah. I mean, it's crazy, right? So they're inherently less reliable these days, I think, even if there's better engineering that goes into it.
It's just a complexity thing.
I think it's just a complexity thing, yeah.
Yeah, because you wouldn't think that the quality,
no,
obviously,
you would think
they spent more back then,
get better, right? Well, you could argue
the
they spent
advances
more,
would help in
advances
fab
in engineering
and
in
materials
manufacturing components and materials and soldering and all sorts of things. There's much more research that's gone into it these days, and they know all the traps.
It very well could last. I really obviously we have no way of knowing that yet, but
no, that's right.
It's amazing looking back at that stuff that it has lasted. It's just.
Well, the other key with these things is the backup systems. They got backups upon backups upon backups, and you can and if it crashes or something, you could take over the backup computer. If you find out there's something wrong with the code, you can re-upload the code. They're very versatile systems. So the versatility is also a reason for their apparent quality, I guess.
Yeah.
And reliability. So it's built into the system design.
Yeah.
I think that's a reason anyway. I could be wrong, but they're great. I love these systems. They're fantastic.
So any other ways to make my system more reliable? You didn't really. I guess power was the only one that you had for me. I'm looking for help here, Dave.
Maybe you've got to get a whole team of NASA guys into, who specialize in reliable systems.
Yeah.
Well, these systems have to be more reliable. They put years and years of just. You simulate everything, right? We just, if we're working on it, if we're one or two engineers working on a board, right, we can't afford to spend 6 months, building systems to simulate aspects of it to make sure when it actually when it's actually built, it does actually work. Whereas that's what these big NASA type systems had to do, right? Everything, you only get one shot at it, so you have to spend, billions and trillions of dollars and thousands and tens of thousands of people, working on every aspect of it to ensure that it does work. Huge difference in physical resources and human resources. If you're just one guy who designed his board, it's like,
Right. Well, you look at the failure rates to get to get past the 6 Sigma mark. Usually, you have to put in, some god-awful amount of effort to get past that, right?
Exactly. You, as the designer, know that, look, I'm sure that 90% of it's going to work and 90% is good enough. We're going to have to respin the board anyway. Right? Well, if you have a few, you expect a few issues on your first spin of the board and you can always respin it, right?
Yeah.
But if that probe's gone into space, you can't just, send another one.
Well, you would respin it a couple times before you'd even send it to testing, right? In that kind of case.
Exactly.
Yeah.
And that's the difference. Okay. It might even be a mindset. Well, it's got to be, it's a resources thing as well, but it's also a mindset issue as well. If it's not, the world's not going to end, or your, $1 billion probe, is going to completely fail if you don't do it right. If it's just a board, right? Do it all the time. I can respin it. Whatever. It's just a different mindset, I think.
Well, so then I guess the next question would be is, the calibration guy you talked to lamented the fact that engineers aren't going into calibration. Do you think the same kind of thing happens with like space type electron? I'm sure there's younger people out there, working on this stuff, but definitely not in the same numbers that are, the aging workforce.
Yeah,
so,
but they're still in their tens of thousands. It's not like there's 2 guys at NASA left with long grey beards who know how all this shit works. If you had a look at all the videos for all the Mars Curiosity rover stuff, like the average age there's got to be less than 30. Of people working on this stuff, they're all young people. Well, they seem
I just
to
figure
be,
those are the ones they put on camera. The other ones are in the back, like
I guess they look better.
growling
I don't know.
and eating gravel, doing all the real calculations. That's just my assumption. No, the ones that were on camera were great too.
No, I think just the sheer size of that endeavor and those endeavors that there's just so many people working on it. You can't sort of lose. It's hard to lose that knowledge. But
maybe.
But you do lose a few things. Like there's no way. If we went to the moon, if we went back to the moon now with humans, right? The mindset is so different these days. We would, some of the stuff that they used and flew in back then, it was like, God, it wouldn't even pass a first crack at an OH&S, safety audit.
Oh, yeah.
Like there's no way you'd send humans up, these days using the methods and the technology they did back then. It's just, it's a different mindset of, people, a different ass-covering mindset these days.
Yeah.
Whereas back then, you just did it, right?
Yeah.
You just, yeah. I don't know. I weep for the future sometimes. Sorry, I have to quote Ferris there.
Well, I wanted to call out a course that is teaching the future in the right way. We've actually mentioned it previously, but Dr. Analog, or Kent Lundberg, he's running a prototyping class at Olin, and we've talked about it before. Mm-hmm. But he's got a blog up, and people can follow it. And I wanted to tell people about it in case they wanted to. So you can actually follow along and effectively take the class alongside them. Like the first,
cool.
I think the first class was like, design a blinking LED circuit. Go.
Right.
Which is great. That's how it goes.
Course.
So I thought it was really cool, and people should check it out. It is a cool way to learn. Definitely different than the massive open online courseware stuff that's out there.
Oh yeah, there's so much of it, isn't there?
There is. Yeah. Have you done any of those yet?
No, I haven't. Well, I've looked at a few. I signed up, as always, right? I've signed up for a couple, and I never get time to actually follow them through, right?
Yeah.
If has anyone actually done these courses and actually followed them through as you're supposed to? Please let us know, because I just haven't got the commitment to do it.
Yeah. Well, I do remember. So Philip Frieden, we've had on the show before, right? From Fliptronics.
Mm.
He said he went through the MIT, the 6.002.
Oh yeah, then that one. Yep.
Yeah,
but that was just one. That was just one class, right?
That was one class, but it was still, like you were actually taking the class. He said it was 20 hours of work a week. I mean, that's
wow. Yeah, you see,
that's for real.
So he actually did it.
Yeah, he did it. Yeah, he got an A.
Oh, awesome.
Yeah.
These things require a huge commitment to actually do them properly, rather than just I sort of watch the video for 5 minutes. I know it all.
It's no webinar, right? It's
exactly.
Yeah,
that's right.
Well,
that's
it's tough too, because it is kind of dry material, right? If you're learning, like, so there's another one on the list from this week about MOS transistors, right? And it's from Coursera, and the Columbia University professor is teaching it. And it's like, if you go through all the different syllabus and all the different things, I mean, like, it's not like, using a MOS transistor to turn on an LED here. It's like, no.
This
is how it works. I mean, this is what's
no
going on.
exciting way to do that. I'm sorry. It's
yeah.
I don't care how nerdy you are. It can be boring. That sort of stuff. Learning the fundamentals like that can be, incredibly boring.
Yeah. I was talking to my wife about this yesterday because traditional schooling, like this kind of stuff, like I agree, it's totally necessary. If you want to learn how to design transistors, you obviously need to know how they work, right? But I was so worked up yesterday because, I've been learning CNC machining, right? I'm working on this mill, and all I want to do is make something first.
Make something, exactly.
Yeah, that's the first thing, right? Because, and what I was saying is, I started thinking about like coursework at school and like high school and college, everything like that. And it really started to get to me because I'm like, God, we just never had context. I mean, some people did, right? I mean, I've talked about, like having hobby work is very important because that gives you context on a lot of stuff. And then you say, oh, I want to learn how to design MOSFETs. I want to go and learn the physics of it, right? And you have this image of what it is in your head. But if you don't have that stuff, if I just, what I was really doing is I was looking at this jig and fixture book that I got out of the library that was suggested to me for machining, right? You need to know how to like hold pieces of metal in order to cut them properly.
Of course.
And it is just the most boring book I have ever read, right? And I was flipping through it and I'm just like, well, it's boring because I have no idea what I'm looking at right now. It's just like that's the tough part of it. And so what I did is I threw it aside, I went back downstairs and I started cutting more stuff, like just kind of figuring it out. And that's the important thing. I don't get why that doesn't happen more.
That's the age-old... Why?
I mean, why in schools? Like, why in schools don't...
Well, we've talked about this a dozen times. About the best way to teach engineering is to start off with the exciting practical aspects of it.
Is it the cost, though? This is what I was talking to my wife about. Is it the cost that does that? Because it's expensive to go, teach people in lab settings versus classroom settings?
No, I don't think so. No, it's just that these, stuffy academic types, they think, oh, yeah, I learned all the theory and that's what I'm going to teach, and they don't, I don't think they have any sense for any other way to do it.
Man. I just, I was really worked up yesterday. It was, the other thing I was thinking about, the other thing I said to her was, I think part of it is like a tradition from, so if you're teaching children, right? So as they're learning, right? There's certain things you can't just start with, right? So if you want to teach someone how acceleration works in a car, this is the example I was using yesterday. You could start teaching calculus, right? That could be eventually, okay, you want to learn about acceleration? Right. Let's start doing derivatives, right? That would be...
Right.
But if you say that to a 6-year-old, there's actual human development issues in there too, right? I mean, there's abstraction and everything like that. So part of it is, yes, you need to have certain math skills in order to learn how acceleration works and the physics behind it and everything and the math behind that. But the thing I don't get is you wouldn't go teach a kid about acceleration without saying, do you know what acceleration is? And they say, no. And then you get them in a car and you hit the gas pedal, right?
Yep,
so that's
exactly.
that's what education needs. They need the gas pedal, right? That they need that initial thing so that then kids could say, oh, I like speed. This is good.
Right.
Or I like blinking an LED, or I like cutting wood with a CNC machine into funny shapes, Oh.
I don't know if we should even cover this again. We've talked about it a dozen times.
But all I can think of, Dave, like what it ends up coming down to is like, I got to start a school. This is what it's going to be. I got to start a school.
Yeah.
I'm screwed. I can't afford a school.
And then you find out, well, you've ultimately got to teach the boring stuff.
You do, and not only that. The way that it's taught now is the easy, not the easy way, but it's more conducive to mass distributed media, right? I mean, doing a lecture is a lot easier than going to someone's house and teaching them something, then go to someone else's house and teaching them something, and ad nauseum.
It is. Oh yeah, it's I've never taught in an academic environment, but I can
thank God
imagine
for
it's
that.
easier. Right? Yeah. I can imagine it's easier if you've got your set plan and you know it all and, you
did it last
just
year.
follow the damn plan. Yeah, you've done it before. You do the same thing every year, so you know it down pat, and then you're not going to have any bastard come along and ask you tricky questions which you can't answer, which makes you look like a dick, right?
Yeah.
But, I can see how that is much easier, but if I was to teach, I wouldn't do that. I would do it more off the cuff. I would go, right, we're going to look at this topic today. Yeah, exactly. Go figure. we're going to talk about this today and then just see where the tangent takes us, right?
Yeah.
And then, it's not, you can't grade that sort of stuff, right? So it's hard.
Right.
I mean, it's,
yes, that's the other part.
It's,
subjective. Did you try today? Did you show up willing to work?
Did you show up and did you contribute, right? That's how I would, and I think every course needs, even schools, right? Even high schools, right? They need, and primary schools, they need sort of informal classes like that, I think.
Yeah.
And but no, and to pass, you've got to not only turn up, but you've got to contribute, right? You've got to actively contribute. You can't just turn up and sit in the corner, right? And just bide your time and just listen, right? You've got to actively participate.
We don't like listeners around here. We like talkers.
Yeah, that's right.
We like doers.
But I know it's impractical because you can't. Well, it's not impractical. You can do it, but then you can't grade it, right? So
right, yeah.
And that's what it all comes down to in the end.
It's a whole new paradigm. Right? It's a whole new thing.
Yeah, exactly.
Papa's got a brand new bag.
Yeah. But see, would, and we may have talked about this before, and I would love it. Like, if I knew that somebody, right, went to some school and let's say, someone like Bob Pease was teaching there, or, any of the Bobs, right? And
your uncle?
Bob's your uncle. Anyway, someone like that was someone really cool was giving one of these informal classes, and you had to participate, and you had to, and if you knew somebody took that class because it had a reputation, because that, the person taking it was absolutely awesome, and you knew what they could, what they could deliver to the students, then I would hire that person over somebody else who got A grades in some freaking academic class, right? So, that could be the differentiator, but...
that's like Larry Sears. We had Larry Sears on the show. That's his class at my alma mater, Case.
Right.
That's that class. You take that class, you pass it, and I hear from someone that you were struggling and enjoyed it, I'll hire you in a second.
I'll hire you. Exactly. Yeah.
And
so,
a lot of universities do have that class, and that's what people should seek out if they're if they're into it.
Yep.
One last
thing
we
should maybe have a rating system, because how does everyone know that that's a good class? You've got to know these people. You've got to, have followed their work or something like that.
Yeah, well, portfolio sites, stuff we've talked about before. Like bringing stuff into interviews. That kind of thing helps.
Yep.
And those kind of classes bring that seed material, right? Like Kent's classes, it brings that seed material where, I tore all this stuff down, I built it back up. Here's all my reports. This is what I enjoyed. This is what I didn't enjoy. That kind of stuff is really helpful. It seeds you with all those ideas for putting in your portfolio.
Absolutely.
So one last question from a listener we had. Basically, he wrote in and he said he was real excited. He's going to community college. He got real excited about this course, and then basically, what we were talking about earlier is he went in these classes and there are all these near retirement teachers. And
right.
They maybe shouldn't be, but they're just kind of going through the motions, and so he's kind of having trouble with it because he got through the program, but it's not helpful, right? And he said he's doing a lot of stuff online and stuff like that. And so his question for us was, should he kind of keep going? Should he go to another maybe a bachelor? I don't know if this was a bachelor's program or not, but go get a master's, go on, that kind of thing, or basically just go out and try and find a job. And
well, if you're doing it, you probably have to, the advice is you have to stick with it and get the bit of paper, I guess, right? That,
Yeah, find the job you want, and then see the minimum you can get to get the piece of paper.
Yeah, I mean,
that's what I emailed him back with too. It's tough,
yeah,
right?
Unfortunately,
you do have to get through
I
this
know,
stuff.
because some schools are a lot better than others. Some teaching, there's vast orders of magnitude difference between various courses, various schools, various teachers, and I was lumped with a lot of, absolutely useless ones, but you hear some other people, I learned so much during this course and it was fantastic, and you go, well, you were lucky, right? You went to one that was good, right? I mean,
yeah.
Well, yeah.
Yep.
That's just
Tough
the reality.
tits.
Some people, some people are going to do a shit course.
Yeah.
And well,
Oh,
yeah,
man,
I know.
Oh, I have stories.
And you can, so do I, right? And you can move, right? If you find that, you can move on, but then onto some other course, try and find one that you like. But then you can spend more time doing that when, you should have just got your bit of paper and then gone in the industry and then, learn on your own and done your own stuff.
Exactly.
Right?
And in this case, networking, right? Trying to find someone to mentor you and then work with them, right? Mentors are going to help you learn a lot of stuff anyways. So see if you can find a mentor in industry, maybe try and get an internship with them, get through to the paper points so you can get past HR. Or if you can sneak past them anyways, just do that. That's a tough problem. It's gotten worse apparently, over the years. You need paper now, whereas you didn't necessarily before.
And he's saying that his fellow classmates feel the same way. He's saying the majority of them feel the same way.
Yeah.
I'm be surprised if he's taken a poll, but you can get the general gist of it. And I mean, sorry, you've just ended up in a shit course, and I've done the same thing. So I feel for you.
Yeah. Well, it's tough too because education's become a really big business, right? I mean, it's just there's a lot of money in it, and so you just got to be careful with that kind of thing. But I think Dave had good advice too. Like if you can move, if it is practical, even getting online to try different online courses, if you can do that kind of thing, that's helpful.
I've moved and kind of sort of regretted it because I ended up into another one which was just as shit. Yet I wasted my time, and should
have come to the States.
Right.
We're number one.
USA,
For now.
USA.
For now.
Oh boy. Yeah. What is it? 40% of Americans can't even point out Africa on a map. Hey, way ahead, dude.
Whatever. So I never learned my states, man. No big deal.
But I can name all 100 presidents, and and the Second Amendment,
That's right. Yeah. All right. Well, that'll do us for this week.
We're done.
We have a bunch more links on the subreddit. People can check that out. Reddit.com/r/the-amp hour.
And always a million things we didn't get around to talking about.
Of course.
Yeah.
I was on iTunes this week, and I was actually updating the feed a little bit. And if people are feeling generous, we would love ratings on iTunes. We think that really helps for bumping us up in ratings and such, and hopefully helping more people find the Amp Hour. So much appreciated.
Yes,
you can rate Dave's EEV blog feed while you're there.
Blog as well.
Too.
Yep.
Yeah, might as well.
It's there somewhere.
It's basically the same thing, right? I mean,
Exactly. Yeah, it's just me waffling on.
Yeah. Indifferent around the world.
Right.
Yeah. All right, man. Well,
that's it.
We'll see you next week.
See you next week. Have we got a guest next week?
We'll see.
Don't know yet, do we? We'll see. All right.
See you.
Later.